Now there is an alternative method. If you prefer the new C++ error handling method, then we could specify that our quadratic function will throw some C++ exceptions. In this case, I've put on the informatory message that we could throw either an integer or a constant char star character string message. The throw on the prototype here, as far as Microsoft is concerned, is merely informatory. Nothing. We'll look down here at the quadratic function next. Quadratic function says it can throw an integer and throw a constant char star. You could throw any number of things. In this case, I'm throwing two possibilities. So the first thing is check. If a is equal to 0, then stop execution, throw a 0 up the line to the C++ error handler. At this point, if a is 0, flow of control will go to the error handler, and it will never, ever, under any circumstances, come back to this function. We are leaving the function permanently. If we pass that test, calculate the determinant, and then put in another explicit test. If the determinant is less than 0, throw a character string, in this case imaginary roots. And again, if that happens, we will go up to the C++ error handler and leave this function forever. Only if we succeed will we calculate root 1 and root 2. Notice this time the quadratic function is a void function. It's not explicitly returning a true or false. No need to. The error handler is taking care of that situation. That means back in the calling program, when you're using the new C++ error handling process, it's a little more complicated. We've got to wrap the potentially failing functions with try-catch logic. So here it says, try the following. Go call quadratic, passing it our three values A, B, C, and the answer slots root 1 and root 2. If nothing happens bad, then we'll output the two answers, root 1 and root 2. However, if the quadratic function throws an error, then say we throw the integer 0, then the C++ error handler looks to see if anybody in the calling sequence is catching an integer. And in this case we say catch int x, and I'll output, hey, error, division by 0, and then just for fun I'll output this integer x. Now notice that this is a useful thing to throw. One could have potentially a dozen different errors being thrown by some complicated piece of software, and in this case you could separate each one up by having a unique integer value and trap them all in one spot and then switch on X and display the appropriate error messages. On the other hand, if that didn't happen and we threw the character string, the constant char star, then we would catch it here with the at this catch statement and output. In this case I just outputted straight the error message that was given to us, and then prompt the user to enter values. One final detail, notice that I put the output of the two roots right here inside the try block. That's because if I had moved it and had it down here above the cout after the try-catch sequence, then no matter what happened with the try-catch sequence, it would always try to output the two answers. And in the case of division by 0 or our imaginary roots, we would be outputting garbage once again, or using garbage values. Now the C++ error handler scheme is a little more complicated to use. It's up to you which way you go. The point I'm trying to make in this first debugging video is an ounce of prevention can save an enormous amount of debug time later. If there is a situation that could cause an error, division by 0, a bad pointer value, all sorts of things, then for heaven's sakes test for it and take the appropriate error handling methods. We'll explore further things with debugging in the next lecture. Thank you.